Welcome to this application presentation of DIC, or digital image correlation, being used for axial and biaxial tensile testing. This application is a biaxial test performed of a cruciform, which is a fillet radii aluminium alloy sample. The biaxial test measurement objective is to measure and compare the principal strain 1, or the major strain, within the four identified areas A, 1, 2, 3, and 4. The second objective is to measure and compare the Z displacement along the two lines L1 and L2. In figure 1 to the top, we can see the camera field of view of the cruciform fillet radii aluminium alloy sample with the marked areas A1 to A4 and lines L1 to L2. In figure 2 below, we see the EduDIC 2D overlay visualization of the Lagrangian principal strain 1 in percentage. The principal strain reaches a maximum of 37 to 38% in regions A1 to A4. As expected, the principal strain is near 0% at the center of the specimen. In graph 1 to the left, we see the principal strain in percent of each areas 1 to 4 marked. Each polygon gauge measurement strain as a mean value across the surface. The max strain A4 is 37% and the minimum strain A2 is 33%. In video 1 to the left, we see the EduDIC 2D overlay visualization of the Lagrangian principal strain 1 in percentage. We can see the strain is concentrating inside the indicated areas A1 to A4. In figure 1 to the top, we see the EduDIC 2D overlay visualization of the contour best plane fit deviation, or the BFP, in millimeters with the marked lines L1 to L2 as virtual line gauges. The distribution of contour deviation is maximum plus 0.44 millimeters to a minimum of minus 0.32 millimeters. In graphs 1 and 2 to the right, we see the spatial graph of the Z coordinate of the respective lines at various acquisition steps. It can be seen throughout the test that the Z deviation develops in the form of a wave.